Welcome to Intro2Astro 2024.
Okay, maybe let's get started. So welcome back, folks, to Intro2Astro 2024. This is the fifth week of our live session. Today we'll be talking about some of the softer skills you need as a astronomer, how to make your CV, how to make your research website, and how to write papers with LaTeX and Overleaf. So our first speaker is Yaguang Li, who's going to show us how to write your own CV. So Yaguang, before you start, could you introduce yourself?
Yes. So hi everyone. My name is Yaguang Li, and I'm currently a postdoc at University of Hawaii. So I worked in many countries. So I was born in China, and then I went to undergrad in Beijing Normal University, and then I take a PhD graduate program at University of Sydney in Australia. And then I moved to Hawaii to begin my first postdoc. So that's where I am here. Should I just begin sharing
Yeah, just
see,
a usual
okay,
Zoom.
okay, cool. So let me share my screen probably. This is probably much easier.
Mhm.
So I think the the CV guideline has already been uploaded on GitHub, so you can also follow that here. So when we're talking about CV, so CV is just really curriculum vitae, and it's basically a document that lists all of your previous accomplishments, your research experience, your past appointments, your publication records. And you will probably gonna need this at all stages of your career. For example, when you're applying for graduate programs, when you're applying for research internships, when you're applying, and even after you have a PhD degree, when you're applying for jobs, even in the industry, we are writing proposals, people will ask you for a CV. And you should have a CV sitting somewhere on your disk and well prepared. So CV is somewhat different from resume. So resume is a very short and condensed version of a CV, which usually only takes like one page. And in academics, CV is more common. And so that's basically the focus of our topic today. So what goes into CV? Like some common categories like your education background. For example, um, where do you get your undergraduate degree? Where did you get your PhD degree? Research experience. So this will be very useful if you're applying for some research-oriented jobs. Honors and awards, publications, and don't worry if you don't have any so far. And also if there are any conferences you attended, whether you presented any posters or talks from there, whether you have done any outreach work. So for a lot of applications, especially at earlier career stage, coursework, your GPA is also very important. So make sure you list them as well. Sometimes we also list our technical skills. For example, like which software or which programming language have been exposed to, something like that. And there are also other optional categories. For example, if you have any particular research interests, and if you have any done any observing before, if you have used any HPCs, high performance computing before. So sometimes if the institute is specifically looking for candidates that have this kind of experience, you might also want to highlight those. Languages, extracurriculums, your references, and also news and media. And there are also some categories that don't belong, so you can give it a read. Okay, I guess if most of you are at very earlier career stage and interested in applying for your next summer research project or grad school, research experience is probably one of the most important section in your CV, right? So for research experience, make sure that you clearly state your position title, your institution, name your advisor, the goal of the research is also very important, because every compact small project comes with a goal. And also make sure that to highlight if there's any final output, whether it's a report, if it's a conference proceeding, or it's a poster, or it's a presentation, something to prove that you're able to complete all of the project and make a great presentation. And meanwhile, you also want to highlight the skills that you have used and developed. And I know some of the employers, when they look at people's CV, they might want specifically look for some of the skill sets. For example, if they are looking for people that are very good at programming, or they want to hire someone that can develop a software, if you can highlight some of those skills, then you have a better chance in getting into the front pool. So there's also some tips about how to make a good CV. I don't know like these are true, but like I'm just gonna go through them anyway. So first of all, I think after today, we're gonna convince you or encourage you to have a CV on overleaf written as a LaTeX template. So remember, CV is an evolving document. So whenever you have some ideas on what you want to put in the CV, you can always go to that document and write it down. Even if it's not in the final polished version, it's fine. The reason to do this is that because if you only update your CV when you're applying for jobs, then it's very easy to forget all the little nitty-gritty details that happen in your life. So it's always a good idea to keep your CV constantly updated. When you have an idea, write it down. And also, it's also a good idea to look at other people's CV to find some inspirations. So you might want to check out some of your favorite professors' personal websites. And their personal websites is usually the place they will upload their CV. So you can take a look from there. And you can find some inspirations and learn from their styles and create your own styles. And also the CV in general is, we have like really, in the academia at least, we have really different expectations for CV at different career stage. For undergraduate, we, like if you're applying for a research program or graduate school, we require all of these basic information, as well as some demonstration of the research experience, right? And if you're a graduate student applying for entry-level postdocs or industry job, we're looking for publications, or we're looking for all of these plus publications. And postdocs is just more and more publications and some evidence of independent research. And the more advanced in your career stage, the more that they are expecting you to have. Like for example, for faculty, people are also looking for if you have experience for student advisory. Have any experience on grant application, proposals? Have you served on any committee? Have you done any outreach? And what are your management skills? Things like that. Okay. So the next advice is put your best accomplishments at the top. So it's very easy to write a super long CV, like maybe 3 or 4 pages or even longer than that. And employers, when they're looking at potentially hundreds of applicants, their CVs, they might not have enough time to carefully go through your CV line by line. So make sure that you highlight the most important messages, put the most important messages at the prominent places. So for example, if you have a stellar publication record, so at the beginning of your publication list, you can say, okay, I have authored X number of first author paper, I've co-authored Y number of papers, my H index is this number, something like that. And if you're applying for example, an institute that is looking for observers, and you happen to have a lot of observing experience, then at the beginning of the observing experience, you can highlight, say, okay, I have observed with X number of nights and Y number of hours, something like that. And yeah, so put your best accomplishments at the top and make it prominent. And another advice is that I would also appreciate that the applicants would, customize the CV for each of their application. So I know this is a lot of work, and sometimes I don't even do this. But just imagine that if an institute, for example, they are specifically looking for an observer, then if your CV is specifically tailored to that skill that they are looking for, you can imagine that can add a lot of points in our applications. And also, if, for example, if they're specifically looking for someone that's, very good at running simulations, running models, if you have applied this number of supercomputing time, you have run this kind of models before, you can definitely highlight those experience and tailor your CV to each of the application, to each of your institute that you're applying for. And also try to seek feedback. After you have a draft ready, ask your friend, ask your advisor, your mentor, get as many people as possible to review your essays. So I would personally think CV is also part of your research application material, is also part of the essay, including your statements, cover letters, your personal websites. So definitely listen to, seek advice from other people. And finally, if like after today, if you go through a lot of people, like your favorite professors, personal websites or CV, and you feel you're quite stressed about the experience, like they all have really stellar experience or whatsoever, don't be stressed. Remember that CV is not everything. It's only a document that detailed documents all of their previous accomplishments, and they surely have failures. They surely have setbacks, and everyone is different and unique, and it's okay to have setbacks. It's okay to take a non-traditional routes. I know a lot of people who take non-traditional routes, and eventually they also reach their goal. So yeah, definitely keep this in mind. So next, I think I'm just gonna pull out Overleaf and quickly demonstrate how to create your CV, a template for a CV. So the platform we're using is called Overleaf. So this is basically, you can imagine this is like a Google Doc, like an online document sharing system for LaTeX. So if you go to Overleaf, this link, and create account. Okay, am I sharing? Okay, I think I'm sharing. Yeah, and if you don't have account, I highly recommend to register one. The free version is pretty much usable, so you don't have to pay anything for it. And then after you're in this interface, you can just click the new project, and under the section templates, you can find there is one called Resume CV, and just click that. The Overleaf has already curated a gallery of resume and CV templates, and you can just go through most of them and find one that you feel is more aesthetically pleasing. Maybe this one. Okay, let's try out this one. So once you click this, and you can click this open as template, and then it will open this template and also save this template as one of your project. So if I go back again to the Overleaf website, you can see this project has saved in my personal list of projects. So I can also just oops. Sorry, my screen is a little bit busy, so I'm just trying to moving things around. Okay, so you can just click this and get into the project and rename this however you want, like my CV, something like that. and you can also upload materials to your personal folders here on the left. So the basic structure of a overleaf or LaTeX template is something like this. So first of all, it defines some basic information about this document, and then all the main information is under this begin document environment. So you can see that for this particular template, it have multiple sections. So the first section is education. The next is career objective. And then it's projects, technical strengths, so on and so forth. So for example, if I want to change something here, okay, let me try to highlight this. Okay, so if I want to try to highlight, change some change the education content here. So what we would do is we modify the content inside the education. And then after modification, if we hit recompile here, and then I think the new content will automatically be refreshed in this part of the document. So here, for example, I didn't went to this school, so went to, for example, the University of Sydney, and then I hit recompile. Then you can see the text can be changed as such. So also, if you want to add or more lines, you can just follow this similar syntax and add more and more contents. Say, for example, if I want to add another experience, say this bit, so I just copy and paste it here and say, okay, if I went to University of Hawaii, and then I'll just say University of Hawaii here and hit recompile. And then you can see the University of Hawaii appear as the third education list here. So I think writing in LaTeX has a lot of tricks, and it might seem very difficult to write in LaTeX as a beginner. So whenever you have a problem, make sure that just Google it. And I think the Overleaf official website has a lot of useful suggestions on how to create your own document. For example, if I want to say, I want to create a table, then you just Google Overleaf create table, and then you can see that from Overleaf, there is a very extensive tutorials teaching you how to make those things happen. Okay, so I think that's all I want to say. Okay, any questions?
Thank you, Guang. Yeah, let's pause for some questions.
Okay.
By the way, we'll cover Overleaf shortly in more detail.
Oh, sorry. I didn't
No
realize
worries.
that.
Yeah.
Okay. You're welcome. Thank you, folks. Ryan asked the question, is there anything that you can put on your CV that you did in high school? So my personal, maybe Faye has other ideas, but my personal experience is that I usually don't put things that I did in high school unless it is related to your academic achievements. for example, if I'm applying for a astronomy research program, if I did something astronomy related, then I would put that. I did that in high school. Put that.
So Ryan, one thing I would add is it depends on your career stage. If you're undergrad looking for a research position as a summer intern, I think experience from high school definitely helps. But once you are a graduate student, then I will only go back to your undergraduate experiences.
Yeah, that's also a great point.
Okay, any more questions for Yaguang? Well, if not, let's thank Yaguang again.
We've been
Our
here.
next topic is making a personal website, and the presenter is myself. In one more moment. Everybody see my slides? Okay, all right. Okay, so the next topic is how to build your personal or research website. Before we talk about the details of how to build the website, let me first of all give you a few reasons why you should have a website in the first place. Well, in academic, a good personal website or research website usually goes a very long way in your scientific career. It can help you find potential collaborations or even help you land a job. So in general, a personal website is a good way for your fellow researchers or even future employer to learn more about you and your research. And the website is more interactive than the CV that Yaguang just talked about. You can include videos, you can include plots, you can include background stories about your research. And there's usually no limit to how much work you can put in there. And in your website, you can be more colloquial in explaining your research. You don't have to be very formal. You can explain everything in layman terms to capture a broader audience. And you can also put your past works in outreach or other collaborations. So if people are interested, for example, you can put a video about your research, for example, on YouTube. And if people are interested, they'll get into contact with you. This may include, potential future advisor. So in general, having a good personal website is a free advertisement for yourself, and it goes a long way in helping you in your science career. So what are some of the key things you should include in your personal website? Well, first of all, a clear, recent picture of yourself so that if people run into you in conferences, they can easily recognize you. And your basic contact information, for example, your email address, your mailing address, your office location if you have one, and your CV, of course. And you should put it somewhere obvious, maybe at the very front, and put a downloadable link so that the people can have the PDF version. You can also write a very short autobiography, your life story, where you grew up, what led you to researching astronomy. And you can also talk about your hobbies outside research. So some of the key things you should include also overlap with CV. For example, your publications, your research highlights. This may include your most recent paper. Or you can just showcase your general view of the current status of your field. what is known, what remains to be explored. What do you think are the most important questions? You can also upload recordings of your own talks. Effective communication in science is very important. You want to showcase you have that kind of skill. Finally, you can also link to some of the research profile, for example, your Google Scholar profile, or for example, your ADS profile that we talked about in week 1. So these are the most up-to-date record of your publication. Okay, so here's a list of some of the other things you can include on your personal website. I wouldn't go through all of them, but in just many of them overlap with the CV material that Yaguang just talked about. Okay, so how do we actually build a website? There are generally 2 ways. The first option is to use a commercial website building tool, for example, Wix.com or Squarespace.com. They're usually free to use and they're very easy to use. But the key thing is sometimes they may ask you for a subscription to provide you with the domain and open your page to the public. The other option is to write your own HTML file. This is usually much more flexible, and actually it is easier than you think if you start with a good template. So here I provided you a link to a good website that contains many useful HTML5 templates. All you have to do is to find a good template you like and replace some of the text and figures in the templates, just as what Yaguang just did earlier. But if you write your own HTML file, the downside is that you need a domain to host your personal website. Usually you can ask your school if they host web page on their department website, and they usually do. The other option is to use GitHub, and GitHub these days provide free domains for your website as long as you have a GitHub account. Okay. Just give me one more minute. So let me share some of the website building tools that's available on the website, on the internet. Let me bring this over. Okay, so one website that's pretty easy to use is called Wix.com. And here is their homepage. And this is their user interface. So you can see this is very user-friendly. You don't need to know coding. All you have to do, is drag, resize. For example, you can change your profile image. I've already uploaded mine, but you can upload your own image too by clicking the button here. And you can easily, just type your name here, type your current position, upload a CV, and put key messages here. So all of these look very similar to Microsoft Word or some of the more user-friendly interfaces. And you can have subpages. For example, here is the contact information. All these are click editable, it's very easy to use. And once you're done updating your website, you can click this publish button. And for Wix.com, there's usually a subscription that you have to pay to host your website to the public. But if you use HTML and GitHub, then there's no such issue. Maybe we can check out my own website on GitHub. Oops, this is the editing page. Let me see. So this is what the backend looks like. You know, just a series of HTML files and some of the images, the files, including a CV here. But the front, let me see if we can show you the front. Yes, so the front looks something like this. You know, having a picture of yourself, your name, your current position, short biography about what you do, and a clickable button for your CV, for example, here. If you click this, bring it to my CV, just as Yaguang showed. It's very convenient for the users. Or you can also embed links on your personal website. For example, currently work at the University of Hawaii, then you can link them on a personal website. And this page is actually my PhD advisor, Josh Win. Okay, so here are some of the research highlights, some of the recent project I did. So you can upload your own images, and you can have separate web page explaining what you did. And you can also embed YouTube videos here to better explain your research. So as you can see, on your personal website, you can put a lot more plots or be more colloquial in the wording so that your research is accessible to wider audience. So I hope I have a whole bunch of past research that I've worked on, you know, and usually also people provide summary of their publications. For example, we look at NASA ADS in week 1. You can actually build your own ADS profile and link it. For example, here, we're looking at my own ADS profile. And so these are all the papers that I have been part of, and it shows you the number of, say, citations over the year. And people can easily access your latest publication this way. Yeah, so your community service and outreach events can also be captured here. For example, we have a link to Intro2Astro and some of the public talks I've given. Yeah, if you feel like it, you can even write a full bio for yourself, like where you grew up, where did you attend undergrad, things like that, and your hobbies, just to make yourself more relatable to people. And at the very end, you should also put some of your contact information. All right, I think that's all there is. Do we have any questions for this part? So one thing I can suggest is to start with a very simple website, maybe just a picture of yourself and some simple autobiography stuff. Then as you progress through your career, you can add more stuff to your website. You know, the very first thing your future employer do is probably to Google you, and you know, instead of them landing on your social media, you may want to show them your research website, which is more professional. Okay, if there's no questions, let's move on to the last part, which is LaTeX and Overleaf. Both are very useful tools for writing papers. or writing your CV too, as Yaguang has showed. So the presenter is Maria. Unfortunately, Maria cannot make it today, but we have a recording of her presentation.
About overleaf and LaTeX. You've probably heard these two words being thrown around a lot. And so it's time that you all know what it means and why it's very important to astronomers. Okay, so what is overleaf? And when I had to answer this question, I realized, let's just look at what Wikipedia has to say. So as it's given here, overleaf is a collaborative cloud-based LaTeX editor used for writing, editing, and publishing scientific documents. It partners with a wide range of scientific publishers to provide official journal LaTeX templates and direct submission links. So if you notice, I have underlined a bunch of words over here because those are the most important keywords to define overleaf. So overleaf is basically like Google Docs, except it's not in a regular word processing format. It's in this thing called LaTeX. And it is very important because it makes writing scientific papers so much easier because it gives you a wide array of templates for journal articles or your research reports or for resumes, things like that. And also, if you have to submit these articles somewhere to a recognized journal, they usually have direct submission links, which makes the process so much smoother than actually having to fill a physical form and then uploading everything. So I mentioned overleaf is like Google Docs and LaTeX. So the next question you would have in mind is, what is LaTeX? It's basically it is a software. It's not exactly a traditional word processor. You have to use plain text following a certain syntax, so like HTML or CSS. And the best part of LaTeX is it produces what you tell it to produce. You put in text, images, you format the text, you format the images, you put in other features, you tell it exactly where to place what, and it does that for you. So I mentioned here that you use plain text following a certain syntax like a markup language. A markup language is like HTML, where you enclose content in tags. So you would have tags telling that, oh, this is the document part, this is the actual part of the document. Or tags to show like this text is in bold, or this text is italicized, or this text has to be aligned a certain way, or this image has to belong on this part of the page. So unlike in a word processor where you simply type, drag, drop, click around, in LaTeX, you literally type it and tell the software what to do and how exactly you want your finished document to look like. There are pros and cons to using LaTeX, which you should know before jumping into this. One of the biggest advantages for me, and I'm sure everyone here will agree to this, equations and inline symbols look great in the typeset results. So typically, if you want to type equations in Word or in Google Docs or in Pages on Apple, you have to go to the insert form. You have to go and insert these equations or the inline symbols from a different keyboard. You have to know what the options are. There are keyboard shortcuts, but it is a little cumbersome. You can't just directly type it in. But with LaTeX, using the right commands, which I will show you shortly, you can actually just simply type it in, and it looks like it's just a part of your regular text and not something that you've added on top of it. In Word and in Pages, I know when you add equations, they look a little different, and they look like images. You can't simply just copy and paste them like you do with text, but in LaTeX, you can. That's a big advantage. Another advantage is once you type up your code or your template for a certain document, you can always reuse it. Maybe it can be for an entire document, maybe it can be just for writing equations or printing tables, but you can keep on reusing it because especially in overleaf, it allows you to save something as a style file, and you can implement that across all the documents you write. It is possible to do this on Pages and on Word as well, but that's more of a page styling thing rather than a text styling or text formatting thing. In LaTeX, it allows you to format text and save that as a template. And last but not the least, well, there are several more pros. These are the three most important ones. But the third one is it's an easier option to cross-reference and for bibliography. So when you're citing things, either in your image captions or in your main text, you can just do // and a tag by which and it calls up whatever whatever resource or article or website that you are supposed to be citing there. How referencing works, I won't be talking about in this little tutorial, but I have some resources linked at the end, and that should give you further understanding. Basically, you can create a separate document that lists all your articles and papers that you're referencing, and then you can call that then later in your main document. So LaTeX sounds great. It has all these pros, but it also has its own disadvantage. One, as you may have figured out by now, it works very differently from a conventional word processing software. So you have to do a bunch of work in the background to actually learn how to use it. It takes a little bit of time. You need to be patient. It is a very steep learning curve. So learning how to use LaTeX is time consuming and may not be the best option if you're going to use it just once in your life. But since you're all here to be astronomers or something related, it is worth your time. Two, tables are not easy to design. So in a word processing software or in like an MS Word or Pages or Google Docs, you can just go insert table and define how many rows and columns you want, and then you can just right-click, add more, or use your shortcuts or whatever. But here you have to use separate commands for inserting a new row. You need to have formatting commands to show where on the page your table should go. It's a little harder. It's a little cumbersome to manage. You need to define separate formatting options to wrap text to keep, if you want to maintain your cells in a certain length, it does not come very naturally. It's not very intuitive always. And sometimes it's kind of like Python where you have to import packages to use certain features. So sometimes it can be frustrating to find the right packages and to even get the basic things right. Sometimes you're missing a package which you didn't realize you were missing. Or maybe you have the package, but you haven't called the right formatting options from it. So, and you're not using it right. So all these things make LaTeX a little cumbersome to use. But if you take the time and if you learn it and you have the right resources at hand, it's actually worth it. So that's fine. And so now let's say you're going to use LaTeX. Overleaf is not the only text editor. Text is LaTeX and text, they're basically the same thing. Text is basically how it was introduced. LaTeX is like text version 2.0, if you may. There are subtle differences between the two, but I'm not going to get into that now. So there are text editors that you can easily download on your desktop and you can work on it offline. Overleaf is an online option. But why would you want to use Overleaf? Because Overleaf is a much, much simpler LaTeX editor option, in short. It not only allows you to write things so in a regular text editor, you have to write everything like you're writing an HTML document, following that syntax that I told you about. But in Overleaf, if you don't know the LaTeX syntax, you can actually write things as a rich text editor, like as though you're formatting things on Word or Google Docs. And everything still works the same, even if you don't know the LaTeX syntax. You will still see this, and just as in a regular text editor, you will still see the types of document that's being created as you edit your main document or you type it up. But the types of document, I mean like the PDF output or however you want to save the output as. So now how to use Overleaf? It's very simple. You go to overleaf.com and you either, if you already have an account, you just straight away log in. If not, you can start up with an account. You can register using your email address or using Google or using your ORCID ID. It's something people typically have when they're writing papers. It's kind of like, how do I describe it? It's kind of like your ID number, but for a world of scientific publishing. It's this unique number that's assigned to you as an author. So when people click that number on papers, they get to access and see everything and anything you've published. And Overleaf can also be connected to your GitHub. So especially if you're using Overleaf to write documentation for code or writing papers or research reports based on the code that you have on GitHub, I think it's a very useful tool. And also some institutions have a premium Overleaf service. So if your institution does, you should find that out. And because premium Overleaf has so many more features, which makes it wonderful. So once you log in, this is what your Overleaf screen looks like. For those of you who used it before, please be aware Overleaf has simply come recently with some more updates. So it looks a little different than it did maybe 2 months ago. So this was a screenshot of LaTeX that I took quite some time ago. This is what it looks like. And you basically click on new project if you want to create a new project. And you have all these bunch of options. You can create a blank project. You can, as I said, if you have something on GitHub, you can import it here. Like usually when you host code on GitHub, you have to create a markdown document. And so you can maybe import that and format it and make it look better on Overleaf. Or you could use anything from these bunch of templates they give. I cannot stress this enough when I say templates are basically your best friend in Overleaf. This option right here, it has a gallery of templates you could use. These are created for free use. They're created by people who use Overleaf all around the world. It can be, you have publishers, scientific journal publishers who have templates on here. And you also have people who created templates for things like a science presentation, a conference poster, maybe how to write a final exam, or maybe you want to write your CV, or maybe you want to write your thesis for college. You have templates for all of that. And so you should always use these templates, or else if you're interested in creating a brand new template of your own, feel free to do that. But for me, I always straight away go to these templates, or you can see I've created a bunch of files. So I just open one of those files and use that as a template for my next file. So once you create a new document, this is what it kind of looks like. This is a sample simple document that I've created just to highlight what the features of an Overleaf window are. So this is the layout of your Overleaf window. So I'm just going to go one by one through the main features here. So over here, so on the left-hand side, you have this panel that has menu-like options. One important one at the bottom is the file outline. So it basically gives you the structure of the document based on whatever sections and subsection headings you've used. So you can see in my main document screen. So this is, by the way, the format of how a LaTeX document looks like, the syntax that I told you about. I'll be exploring this further very soon. So you can see I have a section title saying introduction, another section saying pros and cons, another subsection saying pros. So it just gives that as a file outline just for a person to have a quick view of what your file looks like. And a lot of times, documents created here, when you download it as a PDF and you open it with the PDF viewer, you will see the same file outline if you choose to see it in the PDF viewer. The next important part is creating and uploading a new file to create and upload files and to manage these files. So now an Overleaf document is not necessarily just one main text file. Main.txt is basically where you write it's a conventional name for the main text document where you write up all your information that you want to be printed. But you also have other supporting files. You could have a couple of you could have all the images that you need to put in your LaTeX document. You could have style files, so markdown.sty. STY is a style file, which basically is a pre-created document that tells what formatting you need to do for this document. Then refs.bib. .bib is basically for bibliography. I don't really use it on this document, but it's very handy. And on the top, you can see you have options to create or upload new files or folders or to delete them. And you can upload files either from your computer or you can just pull them in from other Overleaf files. Sort of like how in Google Docs, where you can either upload things from your computer or upload things from your drive. The next thing over here, I've shown you before, source versus rich text. You can either type it like this, as I've shown here, or you can switch to the rich text format if that's more comfortable. Although I would suggest learning this format because it's so much easier and you feel like you're in control. Now, this symbol right here is, you could actually click and choose special symbols instead of directly typing them in. So for example, if you want to print the symbol for alpha, you have to do $sign /alpha, like spell it out and then $sign again. But if you don't want to do that, you can directly insert it from there. But I've started it because it's a premium feature. So if you're a free user, like most of us, you have to type it in. Then review right here tracks edits. Now that is also a premium feature. So that basically works as tracking or reviewing changes like you have in Google Docs or in Microsoft Word. And it's very useful if you're working with a collaborator. Share lets you to share with a co-author. So in a free version, you can share with one more person. If you have a premium account, you can share with multiple co-authors. And it's very helpful when you're writing an article to be published, because usually you would be collaborating with multiple people on a project. And submit here is usually for journal submission. If you're using a template for a journal, let's say you're using an AppJ template, you would directly have a submission link for AAS. So that it's it is a little more fast track than actually having to upload your document, because even for the reviewers, it's easier to manage this. History here shows you the changes you made in the document, you or your collaborators have made in the document over the last 24 hours. If you want all of the history ever since the document was made, again, you'll need a premium account. Now, this is a new option, layout, that manages the layout of this window. This is the standard layout, but you could also manually adjust it by, like, you can see there's a border separating the PDF version and the text version. So you can just drag around, click and drag to manually adjust the layout, or else you could go to the layout options, menu right here for some preset options. Chat is to chat with your co-authors, just like you do in Google Docs. And this little sign right here is to download the PDF version of what you've just printed. The little text paper right there, that symbol is to switch between your output file and LaTeX log. So right here on the right-hand side is the output file or the typeset file. But if you have any problems that is preventing you from getting an output, you may want to switch to the LaTeX log for debugging. So it just works like Python or any programming language where the IDE or the code developing environment would give you an option to debug your code. That is your debugger in LaTeX. And then recompile, it basically is to compile your changes. You could either have that happen automatically, so each time you make a change, it's synchronously updating your PDF document. Now that could be a little memory consuming and a little cumbersome, especially there are a lot of people who are on a LaTeX server at a given time. Or you could compile manually, that you make a bunch of changes and then compile it. Then you compile it after a while. And then you have an option to compile it with or without images. Again, depending on the bandwidth you're on, you want to make a choice. Now, this is the main thing. I skipped the menu option because it has a lot, and this is basically what menu looks like. I just made it 3 panes, but it's actually a single pane that is scrollable, but I just made it for you to just view it better. So in the menu, you can choose to download your files, you could do a main account, you could sync it with your GitHub, your Dropbox, and all of that. You could change how you view the document. So this is how its standard looks. This is its standard appearance, but you could have it have a dark theme. You could change the font. You could change the font of the typeset of the code document. You could change how things look like. You also have a help option if you get stuck with all of this. So these are the main features of LaTeX and how, not LaTeX, of Overleaf, and how to navigate yourself around a document. Now, going into the basic LaTeX template that I created. So this on the left is what I typed. On the right is the output, what I get from whatever I typed. Now to break it down as to what is in here. Every LaTeX document has 2 main parts, a preamble and the document environment. Now the preamble is basically that part like in Python where you import all your packages. You define the type of document you want to create. So document class article is usually the standard, but you have other document classes. Or if you're using a journal template, you want to call that template. For that, you would have an additional file, but that's another thing. So I'm not going to cover that for now. You're going to define a document type, and you're going to import all the packages that you need by calling /use package. And then after the preamble, you have your document environment. Basically, it is the actual content of your document that needs to be displayed, including all the markup type commands. So, your bold, italics, underline, inserting images, inserting equations and tables, that sort of thing. Now, the document also contains your other pages like your bibliography, index, glossary. Those things, they may not be included physically in the document environment. You can create it in other text files, and within the document environment, you can call it. I won't be covering that now because that's a little too advanced for this session, but you have resources where you can look it up. And in the preamble, there are these two things that I want to point you to do. The package, which is basically what you call. So let's say when you're doing import numpy. Numpy is your package, and that's what it's called, package in LaTeX as well. But before certain packages, you see something in square brackets. Now, those are keyword arguments that override default settings. Some packages are set in a certain way, but then, so it's kind of like functions in Python. If you call a function, you will want to define some keyword arguments. Some functions have default arguments. So if you just call the function without those arguments, it's going to behave as it's said to do in default. But you could override the default settings by using these keyword arguments. Now, this was the main document. If you see towards your bottom left, you can see something I wrote as begin figure and end figure. Now, this is creating your figure and figure environment. So right here, to create a figure or a figure environment, you need your image package. Use package GraphicX. GraphicX is your go-to image package. It pretty much works like Pylab or Matplotlib in Python. Now, you want to create a figure, so you can either insert a figure with or without the environment. We always want to do it with the environment because it comes with additional features. So begin and end creates a new environment. It can be a new environment for figures, a new environment for tables, a new environment for lists, a new environment for equations, etc. Here we define begin figure and end figures, so we create a new environment for a figure. Include graphics is basically what inserts the image. So include graphics and the option curly brackets, that calls your image. Now, how does it know which image I'm talking about? If you saw earlier, a couple slides back, in the file on your left-hand side pane, you could upload your image from wherever it's saved. And when you're calling it, Overleaf knows that you're calling an image from this. And whenever you're inserting an image or something external, it always has to be in the same Overleaf file that you're writing your main document in. So include graphics actually includes the image. And if you want to, change its size or crop it, you would want to insert the keyword arguments in square brackets right after you write include graphics. Caption here gives you the figure caption, and it automatically numbers the figure caption for you. So it is so easy to manage. Label here is kind of like a tag. So when you're writing a document, for instance, I want to say figure 1 shows the logo of LaTeX. So instead of writing figure 1, I can always call this image by saying /ref and the /ref and the tag. So here I call it as fig LaTeX fig. So I can call it as /ref fig LaTeX fig, and it automatically puts in the words figure 1 for me. And if you enable it, that actually becomes a clickable link, which lets you jump directly to that image. Now that's all about figures. Now for math, which is the most interesting and easy part of LaTeX, you could either have math inline or you could create a separate equation line. So if you're creating an inline math option, I just put this here. This is literally what you type. You can type whatever words you want, and whatever math you require, you put it between these two $signs. Or if you want to create a separate equation, you create an equation environment by saying begin equation, end equation, and within that you enclose everything you want, and this time you don't need your $signs. An equation environment, just like an image environment, it gives a little number, the equation number there, and you can also add label here, so you can give your equation a name. So let's say, I forgot what this equation was for. It was I just remember it was from some aspect of statistics, astronomy statistics, I think the T factor or something like that. So I can call it label T, I can put the label as T factor and then ref T factor, and it will give me the equation number 32. So as I said, $sign is used for equations, mathematical, and other special symbols. Now, if you see I've written things like an underscore and /frac or a caret sign, now those are for placement. An underscore means subscript, a caret sign means superscript, which is pretty standard across all text editors. And to insert things like the square root symbol or make things look like an up and down fraction, I insert these words. And this equation number I said is inserted by the equation environment. Now for table. Again, for a table, you still need to create a table environment. But if you can see that it has something called begin table and begin tabular. Now, begin tabular is something that is the thing that actually creates a table. Begin table, it lets you put in the other supporting information you need for the table. So if you compare it to our image thing, begin tabular and end tabular is basically the include graphics part of it. Begin table and end table is basically where I put in my captions and labels, etc. And the two things that you need to know here, or three things you need to know here, are how to insert the new row and how to manage the number of columns. To manage the number of columns, we define this little curly bracket thing right after begin tabular. You basically put in these bunch of letters to define how many columns you want, but these letters determine either the size of your column or the alignment. So I put in CCC, which means I want 3 columns where everything is center aligned. If I put LLL, I would have 3 columns with everything left aligned. And if I want lines between my columns, I put in these vertical lines here. If I don't want borders between each column, I simply put CCC and it works out. Or if I just want a border on the exterior of the table, I put line, CCC, line. The double slash here is to insert a new line. It works not only for tables, but also works in the main document. And / H line inserts a horizontal line. Again, it works everywhere and not just in the table. So that's what I have. These are some useful LaTeX resources compiled by NYU Libraries and Harvard Library. This is uploaded as a PDF on the GitHub, so you'll be able to, these are clickable links. And for Overleaf resources, the best one is to go to Overleaf's official tutorials, because they break down everything so beautifully and enables you to use Overleaf very efficiently. And for your assignment, it's very simple. Pick up, and so there won't be a solution key because obviously it's going to differ from person to person, but obviously feel free to ask any of us on Piazza. You basically pick up a topic in astronomy of your choice, and using the Aperture template in Overleaf, you now know how to search for templates. You write a 2-page paper on the topic and you create separate sections on it. You saw how I did that. You just do section, you can create a section, or you can create subsections if you want those. So you create a topic paper with these few sections, and just to get a practice with it, you can include a few images, few occasions, and at least one table. And an extra thing that I did not cover here is to type in references or using a .bib file. The reason I didn't cover this here is so that to give you a motivation to actually go over these resources.
Register now on bit.ly/Intro2Astro 2024.